Yes, we have some, due to some disturbance, the video got stopped. Okay, now continuation of that. Now this was the equation that we have obtained upon substituting the input, and wherever y of t was there, we had substituted by k, isn't it? Now this is differentiation of a constant. K is a constant. What is the differentiation of a constant? It is equal to 0. Correct? Therefore 5 into 0, differentiation of a constant is 0. Therefore 5 into 0 plus 10k, there is no differential element over here, therefore being retained as it is equal to 4. Therefore 5 into 0 is 0, 0 plus 10k is 10k, therefore 10k is equal to 4, or k is equal to 4 by 10, or this is equal to 2 by 5, isn't it? Therefore the value of k is equal to 2 by 5. Right, now this k need to be substituted in the forced response equation. Y of f of t is equal to c1 e to the power of, what was it, minus 2t plus particular solution. Particular solution is a simple constant, alva. Yp of t is a simple constant, therefore k value enide, it is 2 divided by 5. Right, now this is the forced response general equation. Now we need to find the value of c. Before finding k, we should not find the value of the constants c1, c2 or c3. After finding the particular solution only and replacing it by y, its equivalent, then only we should try to find the constants c1, c2, etc, etc. Now to find the forced response, what we have said, all the initial conditions will be making it as 0, isn't it? Therefore let this be equation 5. Now in this entire equation, substitute wherever t is there, substitute by 0. F of 0 is equal to c1 e to the power of 0 plus 2 by 5, which is equal to, now initial condition only, no, idu y of 0 andre initial condition tane. Now we need to make all the initial conditions equal to 0. Therefore this becomes 0 is equal to c1 plus 2 by 5. Therefore c1 is equal to minus 2 by 5. This is the value of c1, and that is the value that I need to substitute there. Therefore equation 5 becomes y to the power of f of t is equal to minus 2 by 5 e to the power of minus 2t plus 2 divided by 5 is the forced response of the given differential equation. Right, we have obtained the forced response of the given differential equation. Only thing that we need to remember in this forced response is, forced response is equal to sum of natural response in its general form plus particular solution. After finding the particular solution value only, we need to substitute this into this forced response expression, and then we need to find the value of this constant, and finally that will be replaced by its equivalent value, and the expression of forced response is this. I hope everybody has understood this. If you have not understood, go back and watch it again and try to understand it. Okay, and try to solve more and more number of numericals with respect to this. Now let us see the other example over here. Right, the next question with respect to forced response is, find the forced response for the system given by 5, the same thing, there is only a slight change over here, 5 d by dt of y of t plus 10 into y of t is equal to 2 into x of t, where with the input x of t equals e to the power of minus t into u of t. Now this is very important here. Even though the above question is same in the earlier case also, this is changed in this question, which is very important. Right, now this is the question, and we need to find what? The forced response. Keep that in your mind. This is not natural response, this is forced response. Therefore the forced response yf of t is equal to y to the power of n of t plus particular solution y to the power of p of t. Let it be equation 1. Now we need to find y to the power of n of t need to be obtained first. Here in this procedure of finding y to the power of n of t, we need to obtain the homogeneous equation. What is the homogeneous equation? 5 into d by dt of y of t plus 10 into y of t is equal to 0 is the homogeneous equation, equation 2. Right, now I need to obtain the characteristic equation upon substituting the differentials by its equivalent r to the power of k. Therefore 5 r to the power of 1 plus 10 r to the power of 0 is equal to 0. Now this is the characteristic equation and let it be equation 3. Upon solving this equation, I will be getting r is equal to minus 2, where the root is real and distinct. Real and distinct. Since the root is real and distinct, the natural response will take the form yn of t is equal to c e to the power of r into t, where r is equal to minus 2. Here I will substitute it directly, therefore it is equal to minus 2t. Let this be equation 4. Therefore equation 1 becomes y to the power of f of t is equal to c e to the power of minus 2t plus y to the power of p of t. Now this is what we need to find now. Let this be equation 5. Therefore now to find the particular solution yp of t. Isn't it? Now in order to find yp of t, what is that we need to look for? We need to look for the input. Since x of t is equal to e to the power of minus t into u of t. The input is in this form. Therefore, particular solution yp of t will take the form e to the power of minus t into k. Correct? E to the power of minus t into k, or constant into e to the power of minus t. This is what the particular solution will take the form. Now, we need to find the value of k. How to find the value of k? We need to denote this by equation 6. Therefore, in this equation of input equation, not homogeneous equation ಗೆ substitute ಮಾಡಬಿಡಬೇಡಿ. ಆಮೇಲೆ you need to substitute yp of t in the main equation. Okay, therefore 5 d by dt of y of t ಜಾಗದಲ್ಲಿ ಏನು ಬರೀಲಿ ನಾನು? k into e to the power of minus t plus 10 into y of t ಜಾಗದಲ್ಲಿ ಮತ್ತೆ ಏನು ಬರೀಬೇಕು? k into e to the power of minus t is equal to 2 into x of t. What is x of t been given? It is into e to the power of minus t into u of t. Even though u of t is not been written also, it is fine, because u of t's value is equal to 1 from 0 to infinity. That is the meaning of this equation, right? Now k is a constant. I can take it outside. Therefore 5k. Differentiation of e to the power of minus t, that is d by dt of e to the power of minus t ಉಳಿಯುತ್ತೆ. ಇಲ್ಲೂ ಕೂಡ k into e to the power of minus t ಹಂಗೆ ಇದೆ, no differential element over there. ಇಲ್ಲಿ 2 into e to the power of minus t ಹಂಗೆ ಉಳ್ಕೊಂತು. Only thing that we need to do here is I need to differentiate this parameter. Therefore it is 5k into differentiation of e to the power of minus k is minus 1 into e to the power of minus t plus 10k e to the power of minus t is equal to 2 e to the power of minus t. Therefore this becomes minus 5k e to the power of minus t plus 10k e to the power of minus t is equal to 2 into e to the power of minus t. Now what is that we are supposed to do here? Next page. Yeah. Now for that particular equation that we have obtained, that is minus 5k e to the power of minus t plus 10k e to the power of minus t is equal to 2 into e to the power of minus t. We are supposed to put t is equal to 0. Put t is equal to 0 in this entire equation. Therefore it becomes minus 5k into e to the power of 0 is 1 plus 10k into e to the power of 0 is 1 is equal to 2 into e to the power of 0 is 2. Okay, we need to substitute t is equal to 0. In order to find the value of k, whatever the substitution we make in LHS, that will also be applied to RHS. Therefore, the meaning of this equation doesn't change. Therefore, if I just apply t is equal to 0 in the above equation, this is the equation that I am going to get. Therefore, this 10k minus 5k is 5k is equal to 2. Therefore, k will be equal to 2 by 5 once again. Right? Now, since k is equal to 2 by 5, therefore the forced response y to the power of f of t is equal to c e to the power of minus 2t plus 2 by 5 into e to the power of minus t, because it was k into e to the power of minus t no in that particular equation. Therefore, here the only unknown is now c. Therefore, we need to apply the initial condition equal to 0. Right? Now, the initial condition need to be equated to 0. Therefore, y to the power of f of 0 is equal to c e to the power of 0 plus 2 by 5 e to the power of 0. Then initial condition, this will be obviously 0 because we are making it 0, is equal to 0 equal to c plus 2 by 5. Therefore, c is here also 2 by 5. Right? Therefore, the forced response y to the power of f of t is equal to 2 by, c value is minus 2 by 5 e to the power of minus 2t plus 2 by 5 into e to the power of minus t. Now I can take out 2 by 5 as a common factor. Therefore, 2 by 5 into e to the power of minus t, because since this is plus, I am writing it first. E to the power of minus t minus e to the power of minus 2t. This is the forced response. Right? This is the forced response of the given differential equation. Hope everybody has understood this. Now, you might have understood by now, based on the input x of t, the particular solution will take the form. Right? If it is a constant, the particular solution will be a constant. If it is a constant into e to the power of minus at, then it is also a constant e to the power of minus at. If it is a cos omega t plus phi, then this will be k1 cos omega t plus k2 sin omega t. Right? This will be, you should remember this table where based on the type of the input, the particular solution will take the corresponding form. Okay, I hope this is clear to everybody. Based on the type of input, its particular solution will take the corresponding form. Right? Now this is about forced response. Now let us see. You should practice with other type of for other type of particular solution as well. As with respect to natural response, input ಏನದು ರೂಟ್ಸು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂತ ಬಂದಾಗ ಏನು ಮಾಡಬೇಕು ಅನ್ನೋದು ಹೇಳಿದ್ದೀನಲ್ವ, ಅದೇ ಥರನೇ ಇಲ್ಲೂ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೊಲ್ಯೂಷನ್ನು ಅದರಲ್ಲಿರೋ ಬರುವಂಥ ಇನ್ಪುಟ್ ಏನಾದ್ರು ಎ ಕಾಸ್ ಒಮೆಗಾ ಟಿ ಪ್ಲಸ್ 5 ಇದ್ದರೆ ಅದಕ್ಕೆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಆಗಿ ದ ನ್ಯಾಚುರಲ್ ಫೋರ್ಸ್ಡ್ ರೆಸ್ಪಾನ್ಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೊಲ್ಯೂಷನ್ ವಿಲ್ ಟೇಕ್ ದ ಫಾರ್ಮ್. ಅದೇನು ಬರುತ್ತೋ ಈಗ ಅದನ್ನು ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು. Okay, now let us see about the total response. The total response. Now this is bit. Now we all know we have discussed about natural response and forced response as well. Therefore, here it is the sum of natural response and forced response. But solving the complete response is not simply the addition of natural response plus forced response alone. Okay, now in order to obtain the total response, we follow a slight different procedure as that as we have followed in obtaining natural response and particular when forced response. Okay, now take the question directly so that we can able to understand the procedure of this. Find the output of the system. See here, they are mentioning the output directly. They are not mentioning the natural response or forced response as such. They are asking us to find the output directly. Therefore, find the output of the system given by the differential equation d square, given by the differential equation d square by dt square y of t, d square by dt square of y of t plus 5 d by dt of y of t plus 4 into y of t is equal to d by dt of x of t, d by dt of x of t, and y of 0 is equal to 0, d by dt of y of t at t is equal to 0 is equal to 1, and the input x of t is equal to, the input x of t equals e to the power of minus 2t into u of t. Now look at this question. Both the initial conditions are also being given and the input form is also being given, isn't it? Now this is, whenever you see such type of questions, suddenly all of a sudden without any second thought you should come to a conclusion that they are asking us to find the total response. Okay, now in order to find the total response, the procedure is slightly different. Follow the procedure carefully, observe my solution carefully so that you can able to understand thoroughly about the obtaining or computation of the complete solution. Now here the total response y of t, here we are not writing y to the power of n of t or y to the power of f of t, it is simply y of t is equal to the natural response plus the particular solution. Just it may seem that this is very much similar to that of forced response, okay, but no, there will be a slight difference in the procedure. Let this be equation 1. The total response y of t is equal to y to the power of n of t plus y to the power of p of t, right? Now as similar to that of it, first we need to find the natural response. Therefore to find the natural response y to the power of n of t, to find this, obviously this differential equation need to be equated to 0 to go obtain the homogeneous equation, and the differentials are need to be substituted by r to the power of k to get the characteristic equation. Now directly I'll be writing the characteristic equation, that is r square plus 5r plus 4 is equal to 0, which is the characteristic equation. You should write the homogeneous equation as well and then the characteristic equation. Now here the roots are r1 is equal to, I will be getting two roots as we have seen this characteristic equation already. There will be two roots, therefore r1 is equal to minus 4 and r2 is equal to minus 1. These are the two roots that we have obtained upon solving this characteristic equation, right? Two roots. Now how these roots are? The roots are real and distinct. They are not repetitive and they are not complex as well. They are simply real and distinct. Therefore the natural response y to the power of n of t will take the form c1 e to the power of r1 into t plus c2 e to the power of r2 into t, which is equal to c1 e to the power of minus 4t plus c2 e to the power of minus 1 into t is minus t. Right, now this is the natural response in its general form. We need not try to find the values of c1 and c2 here itself. 1, equation 2 and say equation 3. Okay, now the particular solution yp of t is equal to, how the input is, in order to know what is that particular solution is taking the form, we need to look for the input, isn't it? Now the input is of the form e to the power of minus at into u of t, which is of the form a into e to the power of minus at. Therefore the particular solution has to take the form k into e to the power of minus at. My a value here is 2, therefore k into e to the power of minus 2t will be the particular solution. Now substituting this equation 4 in the given equation, I'll be getting d square by dt square of k e to the power of minus 2t plus 5 into d by dt of y of t ಜಾಗದಲ್ಲಿ ಇದನ್ನು ಹಾಕಬೇಕು. ಮತ್ತು k e to the power of minus 2t plus 4 into k e to the power of minus 2t y of t ಜಾಗದಲ್ಲಿ is equal to d by dt of x of t ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ಲಿ e to the power of minus 2t into u of t. therefore e to the power of minus 2t ಅಂತ ಬರೆದ್ರೆ ಸಾಕು, because u of t is equal to 1 from 0 to infinity. therefore this is the input that we have obtained. now here after differentiating this, I will be getting k e to the power of minus 2t ನ ಎರಡು ಸತಿ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದ್ರೆ, ಒಂದು ಸತಿ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ, minus 2 into e to the power of minus 2t. ಮತ್ತೆ ಅದನ್ನು ಇನ್ನೊಂದು ಸತಿ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದ್ರೆ minus 2 into minus 2 becomes plus 4. therefore 4k into e to the power of minus 2t. please check it out. ಒಂದೊಂದು ಸ್ಟೆಪ್ಪು ಎಕ್ಸ್ಟ್ರಾ ಆದರೂ ಪರವಾಗಿಲ್ಲ, ಬರೀರಿ ನೀವು. ಪ್ಲಸ್ 5 ಇಂಟು ಇಲ್ಲಿ ಒಂದೇ ಸತಿ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಇದೆ, therefore ಮೈನಸ್ ಬರುತ್ತೆ ಅಲ್ವಾ, minus 2 into 5. therefore this is minus 2 into 5 e to the power of minus 2t. plus this is nowhere having any differential element, therefore it is 4k e to the power of minus 2t. now here it is also a differential element, therefore a differentiation of e to the power of minus at is minus a, e to the power of at is a into differentiation a into e to the power of minus at. correct? therefore this becomes minus 2 into e to the power of minus 2t. upon simplifying this, I will be getting 4k e to the power of minus 2t minus 10 e to the power of minus 2t plus 4k e to the power of minus 2t equals minus 2 into e to the power of minus 2t. ಅರ್ಲಿಯರ್ ನಾವು ಏನು ಮಾಡಿದ್ವಿ, t 0 ಹಾಕ್ಕೊಂಡ್ವಿ ಅಲ್ಲಿ ಅಲ್ವಾ. ಈಗ ಏನು ಮಾಡೋದು ಅಂದರೆ e to the power of minus 2t ಎರಡು ಕಡೆ ಕಾಮನ್ ಇದೆ ತಾನೆ. therefore e to the power of minus 2t ಕಾಮನ್ ತೆಗೆದ್ರೆ ಇಲ್ಲಿ 4k ಮೈನಸ್ ಇಲ್ಲಿ k ಬಂದಿತ್ತಲ್ಲ, ಎಲ್ಲೋಯ್ತು k, ಓಕೆ k, I'll write k here. therefore k10 or minus 10k plus 4k into e to the power of minus 2t is equal to minus 2 into e to the power of minus 2t. e to the power of minus 2t e to the power of minus 2t ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಈಗ 4k 8k minus 10k ಅಂದರೆ minus 2k is equal to minus 2. therefore minus 2 get cancelled, therefore k is equal to 1. correct ತಾನೆ? therefore k is equal to 1 is the value that we are going to get with respect to this equation, isn't it? therefore now ಇದನ್ನೆಲ್ಲಿ substitute ಮಾಡೋಣ, ಇಲ್ಲಿ substitute ಮಾಡೋಣ. therefore equation 4 becomes y to the power of, I'll write it in the next page. therefore y to the power of p of t is equal to k into e to the power of minus 2t. k value 1 ಬಂದಿರೋದ್ರಿಂದ it is simply e to the power of minus 2t, which is the particular solution. now y of t is equal to natural response ಏನು ಬಂದಿದೆ ಜನರಲ್ ಫಾರ್ಮಲ್ಲಿ, c1 e to the power of minus 4t plus c2 e to the power of minus t, c2 e to the power of minus t plus particular solution is e to the power of minus t. now this is y of t. now we need to find the values of c1 and c2. ನಾವು ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ಸ್ ಅಲ್ಲೇನು ಮಾಡ್ತಿದ್ವಿ, ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ಸ್ನೆಲ್ಲ ಝೀರೋ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ತಿದ್ವಿ ಫೋರ್ಸ್ಡ್ ರೆಸ್ಪಾನ್ಸ್ ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ. ಆದರೆ ಇಲ್ಲಿ ಟೋಟಲ್ ರೆಸ್ಪಾನ್ಸ್ ತಾನೇ ನಾವು ಕಂಡುಹಿಡಿತಾ ಇರೋದು. ದೇರ್ ಫೋರ್ ವಿ ಆರ್ ನಾಟ್ ಸಪೋಸ್ ಟು ಮೇಕ್ ದ ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ ಝೀರೋ. ಏನು ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ ಕೊಟ್ಟಿರ್ತಾರೋ ಅದನ್ನು ಹಂಗೆ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಓಕೆ, ನಾವು ದ ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ಸ್ ಗಿವನ್ ಈಸ್, ಯು ಕ್ಯಾನ್ ಚೆಕ್ ದ ಕ್ವೆಶನ್, ಇಟ್ ಈಸ್ y of 0 is equal to 0 and 1 degree first order differential, that is d by dt of y of t at t is equal to 0, its value is equal to 1. therefore we need to make use of those initial conditions in this particular case. therefore ಇದನ್ನು ಈಕ್ವೇಷನ್ 4 5 ಏನಿರುತ್ತೋ ಅದು ಪ್ರೀವಿಯಸ್ ಈಕ್ವೇಷನು ಅದ್ರ ಕಂಟಿನ್ಯೂಯೇಷನ್ ಬರ್ಕೋತಾ ಇದ್ದೀನಿ. therefore 5 ಅಂತ ತಗೊಂಡ್ರೆ ನಾವು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಈಕ್ವೇಷನ್ 5. ಯಾಕೆ ಅಂದರೆ ಇನಿಷಿಯಲ್ ಕಂಡೀಷನಲ್ಲಿ ಒಂದು ಡಿ ಬೈ ಡಿ ಟಿ ಆಫ್ y of t at t is equal to 0 is equal to 1 ಅಂತ ಇರೋದ್ರಿಂದ ಇದನ್ನು ಒಂದು ಸತಿ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿ ಇಟ್ಕೋಬೇಕು ರೆಡಿಯಾಗಿ. ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಈಕ್ವೇಷನ್ 5 ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು t one time, right? therefore the above equation become d by dt of y of t is equal to, ಇದನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಏನ್ರಿ ಆಗುತ್ತೆ, ಒಂದು ಸತಿ -4 c1 e to the power of -4t ಪ್ಲಸ್ ಆಗಲ್ಲ, ಅದು ಮೈನಸ್ ಆಗುತ್ತೆ. -1 ಇಂಟು C2 e to the power of -t ಮೈನಸ್ 2 ಇಂಟು e to the power of -2t. ಒಂದು ಸತಿ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡೋದಿದೆ ತಾನೇ ಆಗೋದು. ನಾವು ಫಾರ್ ದಿಸ್ ಅಪಾನ್ ಪುಟ್ಟಿಂಗ್ t is equal to 0 d by dt of y of t. ಈಗ ಎಲ್ಲಿ t ಇದೆಯೋ ಅಲ್ಲೆಲ್ಲ 0 ಹಾಕ್ಕೋತ ಬಂದರೆ ಏನಾಗುತ್ತೆ, -4c1 e to the power of 0 minus c2 e to the power of 0 minus 2 e to the power of 0. ಅದಕ್ಕೆ ಏನಿದೆ ಕೊಟ್ಟಿದ್ದಾರೆ ವ್ಯಾಲ್ಯೂ 1 ಅಂತ ತಾನೇ ಕೊಟ್ಟಿರೋದು ಇನ್ ದ ಕ್ವೆಶನ್. therefore is equal to 1. I am substituting here. therefore it becomes -4c1 minus c2 e to the power of 0 is 1 minus 2 is equal to 1. therefore it becomes -4c1 minus c2 is equal to 2. ಆ ಕಡೆ ಹೋದರೆ 1 plus 2 is equal to 3. now let this be equation 1. ಈಗ ಸಮ್ ಈಕ್ವೇಷನ್, ಈಗ 5, ಆ ಈಕ್ವೇಷನ್ 5ನೇ ಇನ್ ದಟ್ 5 ಪುಟ್ y of t where t is equal to 0. ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ y of 0 ತಾನೇ ಕೊಟ್ಟಿರೋದು. therefore this becomes y of 0 is equal to c1 e to the power of 0 plus c2 e to the power of 0 plus e to the power of 0 is equal to y of 0 value ಏನು ಕೊಟ್ಟಿರೋದಲ್ಲಿ ಕ್ವೆಶನಲ್ಲಿ, it is equal to 0. it is given already, we are not making it as 0, they have given it. therefore this becomes c1 plus c2 plus 1 is equal to 0 or c1 plus c2 equals -1. this is the other equation. Upon solving these two equations, let this be equation 6 and equation 7. solve these two equations. ಏನು ಬರುತ್ತೆ ವ್ಯಾಲ್ಯೂ ನೀವು ಸಾಲ್ವ್ ಮಾಡಬೇಕು. therefore c1 value will be equal to yes, c1 is -2/3 and c2 is equal to -1/3 ಬರುತ್ತೆ. These are the two values for c1 and c2. now upon substituting there, y of t is equal to c1 value ಏನಿದೆ -2/3 into e to the power of -4t plus c2 ಏನಿದೆ ಮೈನಸ್ ಇರೋದ್ರಿಂದ ಮೈನಸ್ಸೇ ಬರ್ಕೋತೀನಿ, -1/3 e to the power of -t plus e to the power of -2t. right, now this is the complete response. right, now here in this complete response we had not made the input is equal to 0 or otherwise input na 0 ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡು ಮಾಡಿಲ್ಲ ಅಲ್ವಾ. only to find the roots of the characteristic equation ಮಾತ್ರ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ ಅಷ್ಟೇ. and in this case of particular solution ಇಲ್ಲೂ ಕೂಡ ನಾವು ಏನು ಮಾಡಿದ್ದೀವಿ, ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ಸ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀವಿ, ಕೊಟ್ಟಿರೋ ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ಸ್ನ. we are not making any initial conditions equal to 0. we are not making it. if it is there, we are simply following it. if any value is being defined, we are simply taking those value. right, now based on that we have obtained the total response of the given differential equation. likewise, very similar to that of it, based on the roots, natural response will take the form. based on the input, the particular solution will take the corresponding form. okay, based on these two important concepts, you need to find the solution to the differential equation. ನ್ಯಾಚುರಲ್ ರೆಸ್ಪಾನ್ಸ್ ಕಂಡುಹಿಡಿಯೋದು ನೋಡಿದ್ವಿ, ಫೋರ್ಸ್ಡ್ ರೆಸ್ಪಾನ್ಸ್ನ ಕಂಡುಹಿಡಿಯೋದು ನೋಡಿದ್ವಿ. ಈಗ ಟೋಟಲ್ ರೆಸ್ಪಾನ್ಸ್ ವಿ ಹ್ಯಾವ್ ಸೀನ್ ಒನ್ ಎಕ್ಸಾಂಪಲ್ ಹೌ ಟು ಫೈಂಡ್ ದ ಟೋಟಲ್ ರೆಸ್ಪಾನ್ಸ್ ಆಫ್ ದ ಗಿವನ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಈಕ್ವೇಷನ್. okay, now if you have any doubts with respect to it, you can post it personally or you can make a group for signals and systems particularly. ಅದಕ್ಕೆ ಅಂತಲೇ ಒಂದು ಗ್ರೂಪ್ ಮಾಡಿ, ML ನೀವು ಟೆಲಿಕಮ್ಯುನಿಕೇಷನ್ ಇಬ್ಬರು ಸ್ಟೂಡೆಂಟ್ಸು ಒಂದು ಸೇರಿಸಿ ಒಂದು ಸಿಗ್ನಲ್ಸ್ ಆ್ಯಂಡ್ ಸಿಸ್ಟಮ್ ಅಂತ ವಾಟ್ಸಪ್ಪಲ್ಲಿ ಗ್ರೂಪ್ ಮಾಡಿ ಅದರಲ್ಲಿ ಪೋಸ್ಟ್ ಮಾಡಿ. ಇಫ್ ಯು ಹ್ಯಾವ್ ಎನಿ ಡೌಟ್ಸ್ ಐ ವಿಲ್ ಕ್ಲಿಯರ್ if you have any doubts then and there itself. okay, now this is with respect to complete solution or total response of the given differential equation. ಇಲ್ಲಿವರೆಗೂ ನಾವು ಕಂಟಿನ್ಯೂಸ್ ಟೈಮೇ ನೋಡಿರೋದು, ಟೀನೇ ನೋಡ್ಕೊಂಬಂದಿರೋದು, x of t, y of t, so on and so forth. right, now this is with respect to differential equation. ರೈಟ್, ಡಿಫರೆನ್ಸ್ ಈಕ್ವೇಷನ್ಗೂ ಹೋಗೋದಕ್ಕಿಂತ ಮುಂಚೆ ನಾನು ಬ್ಲಾಕ್ ಡಯಾಗ್ರಾಮ್ ರಿಡಕ್ಷನ್ಸ್ನ ಮಾಡಿಬಿಡ್ತೀನಿ. ಓಕೆ, ನಾವು ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿ ಫಾರ್ ಯು ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಐ ಮೀನ್ ರೈಟ್ ದ ಟೆಸ್ಟ್ ಆ್ಯಂಡ್ ಮೂವ್ ಫರ್ದರ್. ಓಕೆ, ಈಗ ನಾನು ಏನು ಮಾಡಿದ್ದೀನೋ ಅಷ್ಟನ್ನೇ ನೋಡ್ಕೋಬೇಡಿ, ಡಿಫ್ರೆಂಟ್ ರೂಟ್ಸಿಗೆ ಡಿಫ್ರೆಂಟ್ ಸೊಲ್ಯೂಷನ್ ಏನೇನು ಬರುತ್ತೆ ಅದನ್ನೆಲ್ಲ ಚೆಕ್ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ, ದಿಸ್ ಈಸ್ ಜಸ್ಟ್ ಎನ್ ಎಕ್ಸಾಂಪಲ್ ಓನ್ಲಿ ಟು ಮೇಕ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ಕ್ಲಿಯರ್ ಟು ಆಲ್ ಆಫ್ ಯು. ಐ ಹ್ಯಾವ್ ಜಸ್ಟ್ ಸಾಲ್ವ್ ಒನ್ ನ್ಯೂಮರಿಕಲ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿಸ್. ಓಕೆ, ಕೀಪ್ ಟ್ರೈಯಿಂಗ್ ವಿತ್ ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ನ್ಯೂಮರಿಕಲ್ಸ್, ಕೀಪ್ ಟ್ರೈಯಿಂಗ್ ಸಾಲ್ವಿಂಗ್ ದ ಕ್ವೆಶನ್ ಪೇಪರ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ವೀಡಿಯೋದಲ್ಲಿ ನಾನು ಬ್ಲಾಕ್ ಡಯಾಗ್ರಾಮ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ಸ್ನ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.